Hello everybody, this is Jason Baker and welcome back to another hands-on segment. In this video, I am going to launch a relational database using the AWS RDS service. Now, before I start to launch my database, I want to cover some network-related things that I've set up in advance. If you recall from the previous hands-on video, I showed you how to create a new VPC, and I've gone ahead and recreated that VPC environment, but I added something extra, and I added an additional subnet. If I go to the VPC dashboard, and if I look at my subnets, you'll see that I have a class public subnet, but then I have two private subnets. And each of these private subnets are in different availability zones. The class private 1A subnet is in the US East 1A availability zone, and the class private 1B subnet is in the US East 1B availability zone. And that's important because when I go to launch an RDS database, by default, the RDS service wants to ensure that it is deploying that database into a VPC that has at least two different subnets that are located in two different availability zones. That's a requirement. And so I have gone and reconfigured this class VPC so that it would have two separate subnets that are in two separate availability zones. Okay, well, now that that's set up, I will go to the RDS dashboard. I'll click on that RDS dashboard. And once I get to that RDS dashboard here, before I launch an actual database instance, I'm going to create what's called a database subnet group. And sometimes students get confused with this naming. When they hear subnet group, they immediately think about VPC subnets. But this isn't a VPC subnet. This is a configuration which we will use that will associate with database instances that we create. And basically what the subnet group is defining is the network location that we may deploy database instances into. And what the database subnet is defining is the VPC and the subnets that are going to be available to the RDS service. We'll go ahead and create a subnet group by clicking on the subnet groups nav link on the left, and we're going to create a database subnet group by clicking the Create Database Subnet Group button. We'll give our database subnet group a name. We'll call this the class-db subnet group. And we'll associate it with our class VPC. We'll go down to subnets. It wants us to define, well, what availability zones do we want to potentially deploy database instances into? And we'll select, we want to select at least two. We'll select US East 1A and 1B. I know that those have been configured in our VPC. And then we can select subnets associated with those availability zones. And I already know that my private subnets use 10.0.5.0 and 10.0.10.0 as the network block ranges. I'll select those. Again, I'm selecting the private subnets, one of which is in US East 1A and the other one is in US East 1B. Okay, those have been selected, and I'll go ahead and create. Again, the key here is that I've got two subnets selected, each of which is in a separate availability zone. I'll create that. It's asking for the database group description. So this description field is required. I'll just say my class database subnet group. And go ahead and click on the create button. Okay. My database subnet group was successfully created. Next, I'm going to click on the databases link on the left. And this shows me any databases that are currently running within this region of my account. I don't have any yet. I'll click on the Create Database button on the right. And I'm going to close some of those messages at the top. This is where I will create my relational database. It asks for what kind of creation method do I want to use, the standard or the easy method. We don't want to use the shortcut method, so we want to use the standard creation method in our class. And next we will select the engine type. There are a number of very common, very popular relational database engines that we can choose from in RDS. We are going to use, for this example, the MySQL database engine. We can scroll down and select a specific version of the MySQL engine. It doesn't really matter for this particular example what version you select. You can just go with the default for now. Of course, in your environment, in your corporate environment, your application development team may require a very, very specific database version. We can select from a number of templates. These are sort of like options that we can choose, and based upon whether we're running a production database or a development database, or we just want to deploy something for learning purposes on the free tier, AWS will automatically make some sensible choices for us. We'll go ahead and select the free tier option here. Go down and to the settings area. We can name our database instance. In this case, we'll call it our class DB1 instance, class DB1. And then we can set up some credentials. Now, these credentials are not the credentials that we would use to terminal into the database instance, because we can't access the database instance shell. This is a fully managed instance that's managed by AWS. So we don't actually have shell access to this instance. However, we can get access to the database service that is running on the instance. And we can do that using a master username and a master password. I'm going to select, I'll just use the default admin. And in this case, I'll select the auto-generate password, because I'm not actually going to log into this particular instance right now. But if normally you would probably just specify a master password and then confirm that password. I'll just have it auto-generate for now. Scroll down to database instance class. Just like EC2 instances, our database instance also will have an instance class defined. And based upon the instance class, we can allocate a certain amount of CPU and memory and networking performance to a database instance. We're going to just leave it at the default db.t2.micro instance size. For storage, we can define how much storage we want to allocate. We'll leave it at the default of 20 gigabytes. We can enable storage auto-scaling. That's enabled by default, and that's an awesome feature, because what that will allow us to do is automatically scale the amount of data, the amount of storage allocated to our database instance based upon the size of the amount of data that we're storing in the database. Traditionally, this was kind of a tricky thing to manage, because Traditionally you would set the amount of storage size associated with the database server. And if you ran out of storage space, then you would potentially have a major problem on your hands because number one, you would lose data potentially, and two, you could potentially crash the database instance. And so if you're getting close to using up the amount of storage on that database instance, then you'd have to jump through a bunch of hoops and go through a relatively complex process to get more database storage and potentially even migrate your data over to a new database instance. Well, in this case, AWS can automatically increase the amount of storage for the database and do that as a maintenance operation, which is fantastic. I'll keep scrolling down, and this database is running in a single availability zone. You can set up database clustering, which allows you to run your database across multiple availability zones for high availability. We're not going to do that in this case. For connectivity, we want to deploy this database into our class VPC. I'll select our class VPC. And then you see the subnet group automatically changed here to that class database subnet group that we had provisioned earlier. Public access we'll leave at no. We generally do not set up public access to RDS instances. I can't think of a time where I've ever done that in my career. And generally, you wouldn't want to let people from the internet directly access your RDS instances. For VPC Security Group, we're going to create a new one, and we'll just call this we'll call it the class DB-SG, class DB Security Group. And we don't have an availability zone preference. We could specify that we want this to run in US East 1 or US East 1A or US East 1B availability zones. And depending upon your network architecture, you might want to specify which AZ the database is running in. For this example, we don't really care, so I'll leave it at no preference. I'll expand the additional configuration option. We could optionally define a specific database port that the database service should listen on. The number 3306 is the standard port for MySQL. We'll leave it at that port number. For database authentication, we'll also leave that at the default password authentication. There are some other more advanced options that are available there. I'll expand the additional configuration settings, and here we can set things like the database parameter group and option group. These are things that you might do in your organization depending upon how you want that database server to be configured. In most cases, I'll leave these at the default, which represent a set of sane default values. The backups are automatically enabled for our RDS instance. AWS can automatically back up our database instance on a daily basis, and it can retain those backups for a set number of days. The default is 7 days. It can retain them up to 35 days. If you need more than 35 days worth of database data retention, then there are ways to do that are more complex and that aren't covered here. You can also, if I keep scrolling down, enable maintenance for the database instance. Again, this database instance is maintained by AWS. They actually provision and install the database software and maintain it. By default, they can automatically enable minor version upgrades. So these are things like security patches and bug fixes. It's oftentimes a good idea to enable that automated updating of the database instance. You can, of course, turn that off if you want to do it yourself as well. Lastly, we can enable deletion protection, which I think is generally a good thing to enable for databases in RDS. What this prevents is somebody coming along and accidentally selecting your database instance in the database web console and terminating it, which could have a major impact on applications that are using that database instance. We'll go ahead and we'll enable that deletion protection and scroll down. It gives us some idea of what the monthly costs might be for this database instance, and everything looks good. So we'll go ahead and create the database by clicking on the Create Database button. When I do that, then it takes me to the database dashboard, and it tells me that it is launching my new database. Now, RDS databases can take a bit of time to launch. They can take 15 minutes or so to launch. And during the database creation process, like one of the first things that it will do is it will actually snapshot the database, so it performs its first backup of the database, even though there's no data in the database yet. And that snapshotting process can take a little bit of time. I will pause the video here and we'll wait for that database to launch completely. About 10 minutes and my RDS database is now available. As you can see, if I select my database, you will see a number of configuration details describing the database, the availability zone that it's been deployed into, in the VPC. We can look at the configuration tab. It'll tell us the instance size of the database engine that it's using. You can see the creation time, the storage size, so all the different configuration options for our database. If I go back to the connectivity for the database, probably the most important thing to understand is the endpoint, the database endpoint, which is this value right here, the database endpoint. This is the endpoint address that we would provide to our software applications that need to communicate with this database instance. And so if I had like a web application that was communicating with this database server, I would use this as the database address. I'd plug that into my application, and then I would provide my application potentially the username and password that I had created for that database instance. So that's how we can easily create new RDS database instances. Now, if I go up to the database list, and if I want to get rid of this database, I can select it and say application actions, go ahead and delete. And it tells me, oops, you can't delete the database because the deletion protection option is enabled. Remember, I enabled that. I'll go back to the modify database instance. And in modify database instance, I can make some changes to the database configuration. In this case, I want to disable that deletion protection. I'll click on continue, and I want to apply this change immediately. I'll modify that database instance. So it tells me it successfully modified the instance configuration. And now I can go to actions and say delete. And when I delete the database instance, I can optionally create a final snapshot. And usually, like if this is a production database, that's a good idea to create one more backup just in case, because if I have to quickly restore this database again, then I could use that snapshot to restore all the data back into that database instance. In this case, I'm just using this for demonstration purposes, and so I will not create a final snapshot, and I'll acknowledge that I don't want to create the database snapshot, and then or to delete it, then I type in the phrase delete me into that deletion field. Finally, I click on the delete button to delete that database. And again, it'll take a few minutes to delete the database. If I had selected the final snapshot option, then it would take an even longer. If you have a very large database, it can take a long time to snapshot the database. I've worked with databases that are tens of terabytes in size, and it's taken hours to snapshot a database. So that's something that you can always want to keep in mind as well. Well, I hope you enjoyed this hands-on segment, and I hope you're looking forward to the next one. Thank you.